Good evening, students. In this video, we are going to discuss about what is state reduction or state minimization. So, state reduction is nothing but it is used to reduce the number of states in a sequential circuit. From the name itself, we know that. And what is the purpose of it means to reduce the complexity of the sequential circuit. Because, say, for an example, if suppose your sequential circuit has a 9 states and some states are repeated, then we can use it only once. So that what would happen means instead of a 9 states, we can represent the same sequential circuit with the help of only 7 or 6 states, 6 states only. So now what would happen? So due to this reduction, your flip-flop, the number of flip-flops required for the given sequential circuit design is also will get reduces. So for that purpose only, we are going to use state reduction or state minimization. So now we'll see to that the state reduction concept with one example. So now this is your given problem statement. Construct the state diagram for the following circuit for the following state diagram. So actually this is a state diagram of the Mealy model, because already we know that Mealy means your next state or your output that will be based on your present state as well as a present input. So see to that now here, if A is a present state, okay, and next state again will be a if suppose your present state and present input is a 0. Similarly, if A is a present state and B is a next state, when your B is a next state for the with respect to A means your present input as well as a present state will be 1 0 in that case. So likewise, based on this Mealy model, we can construct the state table. Now see to that your state table, your input is considered as a X, and then your output will be considered as a Y. So now your state table is consist of a 3 sections: present state, next state, and output. So present state is a and next state will be a A. When it is said to be a means your X value it is equivalent to 0. Okay, and if suppose your X value is equivalent to 1, your next state will be B. Similarly, your output Y is based on your X equivalent to 0 and X equivalent to 1. So your output is now 0. If it is in case of 0, your X value is a 0 here. So here input is X. Actually, this is called X slash Y. So here see to that your present state will be the A and next state will be the again A. If suppose your present input will be the 0. Otherwise it is B. Similarly, your output will be in all the cases, that is 0 or 1. X value 0 or X value is 1. Your output Y is 0 0. So that's why see to that here we have 0 0. Okay, likewise we need to construct the state table here. Again, for one example, I am taking this present state D. If suppose your present state is a D, now this is your present state D. If in D is a present state, then next state will be the E. If suppose your X value is equivalent to 0. Similarly, what is your output? For the X value equivalent to 0, output is a 0. Y X. Okay, Y value is a 0. Similarly, if suppose your present state will be the D, then your present input X equivalent to 1, then your next state will be the X. Similarly, your output will be the 1. Okay, so likewise here, see to that. D means E, F and 0, 1. Likewise, we need to construct this state table. So now in the state table, we are going to do the state reduction. So if the next state and output is the same, next state, see to that A, E and F. Similarly, your output, okay, your output and next state will be the same, then eliminate the last state. So see to that here, G, A, F, 0, 1. Similarly, here also if suppose your present state is an E, then your next state will be A, F, and output is also 0, 1. That is, we need to compare this present state with all the other states. Okay, and all these conditions, that is, your next state when x equivalent to 0, your next state when x equivalent to 1, and in your output when x equivalent to 0, when x equivalent to 1, everything it must be the same. Then only we need to do the state reduction. And also the state reduction that will be from the last state we need to do. So here see to that your G, okay, as well as a E. So both the states is having a same next state as well as the same output for your x value equivalent to 0 and x value equivalent to 1. So that's why we need to eliminate this last state, that is G. Okay, that is replace this G by E in the state table. Okay, so wherever we are using this G, okay, so now that can be replaced with your replace the G by the value E. So here see to that we have a G. So now here it is E. Okay, so eliminate the last state, and for the remaining table, whenever you have an element G, then you have to replace this G with E. Now your next state will become, now your reduced state table will become, see to that how many states, only 6 states. So from 7 it is reduced to the 6. Now see to that again your last state will be the F, means your next state will be E and F, and here the output is a 0 and 1. Similarly here also your both the states are the same next state as well as the same output. Now we have to remove this F, and wherever we have a F in this table, then we have to replace this F with D. Okay, so now your reduced state table will become like this. Okay, so here your reduced table, how many states it's having? Only the 5 states. So from 7 it is reduced to the 5. Okay, so now this is your reduced state diagram. So in your question, if suppose asking only the state reduction and a reduced state diagram, then you can do the steps up to this. When they are asking a design, then only you go for the design part for the reduced state diagram. Otherwise, this is sufficient. Thank you.